Multiply them together, it gives me my desired result. Last one, x squared and 6x to the third. Yes?
X, and then in parentheses, it would be x plus 6x.
I do not deny that these indeed are factors. However, I will argue that x is not the greatest of the common factors. Brenna, what would you change? If I make this an x squared, what would I have to change this to in order to get a product of x squared?
You don't have it, right?
Well, x squared times what gives me x squared?
X squared. Well, no.
Not 0, 1. So I'm going to change this to a 1. And what would I have to change this 6x squared to? Just 6x. I like that better because this is the greatest of the common factors. Indeed, x was a common factor, but it wasn't the greatest one. So I want to pull out sort of as much as humanly possible. Fair enough? Phase 1, complete. Little review here. I believe it was Mr. Rooney did this a few weeks ago with you. He taught you the FOIL process. Is that true, Mr. Rooney?
Yeah,
Was
who
it
can
you?
remember?
Was it
We
you?
did some.
Okay. FOIL process, or as I like to refer to it, double distribution. Those in my E-block class, this will sound very familiar from 20 minutes ago. We have a binomial multiplied by a binomial. It means we have to do 4 sets of multiplication. X times x? Not 2x. X squared. X times 4?
4x.
1 times x? And 1 times 4.
4.
Like terms that are combinable?
4x and x.
4x and x, which would give me a total of 5x. So I get x squared plus my 5x plus my 4. I would like you to take 3 minutes. Shouldn't take more than that. Double distribute numbers 2, 3, 4, 5, and 6. And we will reconvene to see if we see a pattern.
Okay, so there's one of the two that I have.
You only get 2?
I'm begging, so I can
Mine,
down.
mine's one that has a hard one. While you guys are performing this task, I'm going to pass around the sign-in sheet. Again, please make sure you clip your purple sheet underneath.
Bassett, please report to the main office. Benjamin Bassett, please report to the main office.
More seconds. Get down as many as you can, please. I know we're pressed for time today. All right, number 2, it results in a trinomial. Who knows my desired trinomial? What's my desired product? Yes, sir.
X squared minus 3x minus 4.
X squared minus 3x minus 4. Agree. Number 3, what is the desired trinomial here? Yes.
X squared plus 16x plus 60.
Perfect. Number 4. Rowie. Minus 60, he says? Agreed. Number 5. Anyone get to number 5? Then I will spoil the surprise. Oh, Marina, you got this one?
X squared plus 4x minus 60.
Well done. Did anyone get to number 6? Yes.
X squared
There's more to it than that.
minus
Ethan?
36.
Minus 36. All right, there's a little blank. It says, do you see a pattern? Did anyone catch a pattern that would actually make your life a whole lot easier? Yes, which pattern? They all start with an x squared. Makes life easier. Anyone see anything beyond that? What'd you say? Yep. You got one?
Oh, yeah, sorry. The outcome, like on one of the numbers, turns out to be like, for example, negative 6 times 6 is negative 30.
Negative 6 times 6 is negative 36. What's negative 6 times 10? What's 6 times negative 10? What's 1 times 4? So that last term is always the product of, let's call them the parentheses numbers. That's a nice one. We know it starts with an x squared. We know it's going to finish with that product of those two numbers. What about that middle piece? Cool little pattern here, Rowie. It's the what? It has a number and a variable. In this case, x. What's true about that number? There's something special about that number. Marina.
Oh, the number in the last parentheses is the number.
Not always. This one's got a 4, but here we had a 6 and a 10. This one's got a 4. It's not always the number from there.
It's both the numbers added together.
It is the sum of what we'll call our parentheses numbers.
Is there a name for those?
Not really. It's a neat pattern. I don't think it has an official name. I know 1 plus negative 4 is negative 3. I know 6 plus 10 is 16. I know 6 minus 10 is negative 4. I know negative 6 and 10 is positive 4. And I know negative 6 and positive 6 is negative 6 and positive 6? 0, which is why I didn't end up with a middle term here. It's actually like x squared plus 0x minus 36. Interesting pattern, right? Leads us into our next vocabulary term, quadratic polynomial. We spoke a few weeks ago about degree. What degree are all of these polynomials that are listed here, numbers 1 through 6? What degree? They are second degree polynomials. So second degree. And they always come in the form a x squared plus bx plus c. There's something multiplied by x squared plus some middle term multiplied by x plus some final term which does not have a variable with it whatsoever. The only exception would be number 6, because what's the coefficient of that middle term? 0, which is why it doesn't really appear. But it could be there. We could write it as x squared 0x minus 36, so it still looks trinomial-like. Number 7 and number 8. I would like you to take a moment. I would like you to do your double distribution on number 7 and number 8. Don't try any shortcuts. They're not going to work here. There's a fatal flaw to number 7 and 8, and it's because they now have lead coefficients that are not just the number 1. So take a couple minutes, do your double distribution down here.